Hey everyone, welcome. Today's video is about Algebra 1, evaluating and solving equations. In all classes up until taking algebra, before we mainly dealt with constants, which were items of numerical value. Specifically, these were items that had what we call known value. You know that 5 equals 5, 35 equals 35, 200 equals 200. So I'm going to write some examples here for visual purposes. And these can be big numbers, they can be small numbers, they can have decimals, whole numbers, or not be whole numbers. They're a mixture of all the above. But now that we're in algebra, we have something called a variable. And a variable is a symbol of an unknown value. Key word that's important is unknown. And that is what one could describe algebra as being, is using the properties that we are taught to find the values of the unknown values, that the unknown symbols that we're given. So the most popular unknowns that you'll see used in algebra are X and Y. I'll put Z in there. And you'll also see some items from the Greek alphabet often. So I'll put some in there for you. So we have theta, I can put gamma, and beta is used often. There are plenty more, but this is, again, just for visual purposes, so you can start to familiarize with it. Now, going to before, we had something called numerical expressions, where each part of the expression had something that was a number that we had a known value of. But now that we're in algebra, we have expressions that have both a numerical and a variable inside. And that's why they're called algebraic, because there's some part of that expression that we do not know yet. So I'm going to write some examples again for visual purposes. And these are arbitrary, so that I'm picking. So 5 plus 392, $3.60 plus 85 cents. And then I'm going to do a division one. So let's put 1200 divided by 48. In each case, it's number, numerical value, numerical value, numerical value, again, numerical value at the top, numerical value at the bottom. But when you get an algebraic expression, you will have numerical value, but you'll also have a variable. So to compare, I'm going to do 5, but instead of putting another numerical value like I did on the left side, I'm going to put plus y. This variable is something we do not know, and we're just going to leave that at that right now. And we're probably going to have to figure out what the value is, unless they give it to us later. Another example, I'm going to put 2 theta plus 3.14. And then let's do, since we did division over here, we'll do multiplication. So I'll put 25,000 J. And this is to iterate, since they're written close together, that we have 25,000 times the variable of J. We do not know what J is yet. In algebra, you'll be asked to do a couple of things, and one of those may be that they want you to evaluate something. So when you're evaluating something, that means they want you to find the value. So evaluating algebraic expressions is to replace each variable with its stated value to find the value of the unknown expression. That's the key word, stated value. They're going to tell you what the value is. So you can then find the value of the whole expression. I have 2 examples below. The first one is evaluate 5 plus y when y equals 13. 5, I'm not going to write y again. I'm just going to put 13 because that's what they told me to be. So then I'll do the math. And the value of the whole expression is 18. So we evaluated it. Second example, it's saying 300 plus y minus z when y is equal to 14 and z is equal to 10. So 300 plus, I'm not going to put y, I'm going to put 14 because that's its stated value, what we have highlighted, minus the stated value of z, which is 10. And then when you do the math for that, it is 304. In algebra, we have these things called equations, and an equation states that two expressions have equal value. So you will see an equal sign present, and that's what we have here in this example that we'll talk about in a little bit. And in algebra, one or both of these sides contain a variable. In this example, there's a variable on one side. You'll see in further examples that you can have a variable on both. And the goal is to find the solution that makes the equation. So I'm going to highlight that part. The goal is to find the solution. Back here, when we were talking about evaluating, they gave us a stated value. Here, we have to find a value. We're finding the solution, which is a value. So in this next example, I have here, find the equation solution, x minus 10 is equal to 14. There are two steps. You isolate the variable, which means you put that you're going to have the variable on one side. In this example, the variable has another term next to it. Isolating the variable means we're going to have x eventually by itself. Once we do that, the next thing is solve by finding the variable's value. Isolating the variable which was this first step here for solving an equation, requires you to perform equal actions on both sides using the properties of equality, which I'll explain below on this page, of the equation that results in the variable being alone on one side of the equation. So I'll read that again. We're performing equal actions on both sides of the equation that results in the variable being alone on one side of the equation. Performing equal actions is important on both sides that results in the variable being isolated. Being alone, being isolated is the same thing. The properties of equality that definition spoke of are the addition property, the subtraction property, the multiplication property, and the division property. These properties state that whatever you do on one side, the left side, you have to do on the right side and vice versa. So the addition property says if you add something, let me change that. If you add something on the left side, you have to add on the right side. So if I add C here, then it means I have to add C on this side. The subtraction quality saying if I subtract something on one side, I must do the same thing on the other. So if I subtract C from the left side, I must subtract C from the right. Multiplication says that if I multiply anything on the left side, I must do it on the right. So I'm going to use, I'll put the times sign, C times C. Same thing, if I divide on the left side, I must divide on the right. This will be shown much more often as we practice in problems. So the first one, we'll start here. Sorry about that. We have an example of x minus 10 is equal to 14. The first step we talked about was that we have to isolate the variable. So here, the variable has a negative 10 next to it. So in order to isolate it, I have to get rid of it. And if I have a negative 10, that means I have to add by 10. So I'm going to do that here. So according to the addition property, if I added 10 on this side, I have to add a 10 on the next side. So I'm going to add 10 here as well. That cancels out, and then x is isolated. Then I do the math. 14 plus 10 is 24. And at that point, we have solved the equation. We have another example. This particular example has a variable on both sides because it has 5b and 2b, and then it has a b here. So this example, variable on one side, it only had an x, but b is on both sides. Variable on both sides. This has an added step, which is simplification, which wasn't there before, just because this has more terms and it can be simplified. And combining like terms and or using the distributive property, which I'll explain later on in this video, are ways that you simplify. Once it's simplified, it's similar to the last example with only one variable. You're going to isolate the variable and you're going to solve by finding the variable's value. So with this one, we have 3, minus 5b plus 2b is equal to negative 2 minus 2 parentheses 1 minus b. Simplification, put here, will involve combining like terms. I'll just put simplify. That's what we're going to see first. So on the left side, I have a negative 5b and a 2b. That can be combined. So I'm going to do 3 and then combine them, do the math. So negative 5b plus 2b makes it negative 3b. That's the left side. Then looking at the right side, I can distribute what's outside the parentheses of negative 2 to the inside of the parentheses. And so I'll write what the distributive property is right on this right side really quick. I'll put FYI, distributive property. Is when you have A, parentheses B plus C, in parentheses. You can distribute that A to the first term and to the second term. So then you have A times B plus A times C. We're going to do the same thing here. I'll also put another FYI that, put this on this side. That's an ugly line, hold on. That practice problems are linked in the description of this video below. I highly suggest in learning this material that you look through those videos to help your understanding of doing it by yourself. I walk you through a good amount. There's a video for easy to intermediate, and there's also a video separate for difficult problems. Those difficult problems will get you. So that's why I like to give you several examples, because with practice, that's how you get more comfortable. So let's get back to the example. So on the right side, we're going to do the distributive part. So we're going to distribute the negative 2 here and the negative 2 here. So I'll bring down the negative 2, and then negative 2 times 1 is going to be negative 2, and then negative 2 times negative b is going to be positive 2b. Simplify some more. This is the same, can't be simplified anymore on the left, but negative 2 minus negative 2 is negative 4 minus 2b. Now, I need to bring the b's to one side and the constants to another. So, I'm going to bring negative 2. I'm sorry, I wrote that wrong. I'm going to bring 2b over, so I'm going to subtract 2b. Whatever I did on the left side, I have to do the right, so negative 2b. That's canceled. Then you got 3 minus 5b is equal to negative 4. Bring this constant over to be on this side, negative 3. So if I did it on the left, I do it over here. That cancels, and then I have negative 5b is equal to negative 7. To get this finally isolated, since it is multiplied by negative 5, I have to divide it by negative 5. So I must divide it by negative 5 on this side. B is finally by itself and isolated. And then you have positive 7 over 5. And there you have it. If you guys have any questions, feel free to possibly set up a one-on-one session via my email. That's linked in my About Me section. And I hope this was helpful. See you guys in the practice problems.